In this video, we're going to continue our discussion regarding slope, and today's focus is slope from the table. So tables are really useful to us. They organize our information, and our focus today is to determine the pattern, okay, the pattern of our data. So we are still looking to make sure that we have linear data, so the pattern that we're going to be looking for is going to have very specific relationships. So we have two different methods. So when we are given a table, we need to identify the pattern or rate of change. So the pattern that they're discussing is our rate of change. We have worked with rate of change previously. We're just going to come back to this particular concept. So rate of change tells us to determine what are the changes that we're observing in Y values and X values. So when we say changes, we would say from -8 to -3. We have increase of information, increase of values. By how much? By 5. From -3 to 2, how much did we increase? By 5. 2 to 7, 7 to 12, yeah. Each of them is changed by 5. So we're literally analyzing our table in this particular relationship. Change in Y, and yes, compared to change in X. Okay, sometimes you will see these look like a triangle. It is Greek letter delta that represents the change. All right, so we have determined that the Y changed by 5. Okay, and so we do the same type of analysis for X values. -2 to -1, 0, 1, 2, all of these are changing by 1. And here is your rate of change, aka your slope, reduces to 5. So my biggest, huge request for you, do not set up the ratios for like we did for constant of proportionality. So what we've done before, so I'm going to say do not -8 over -2, 2 to 0, 7 to 1. You might say, oh, no. There's no slope. There's no rate of change in here. So do not do that. Super important. You're like, oh, the rate of change, saying how are our values changing? They changing by 5. They changing by 1. So both values are growing. So you do have your numbers recorded. +5, it grows by 5. +1, it grows by 1. And here's your data. Another tool that we can use our tables for is to determine Y-intercepts. So I am going to go ahead and label that. Your Y-intercept is right here, my friends, right here in this value. No, went wrong direction. My apologies. Wipe all of this out. So Y-axis, a Y-intercept, not Y-axis, is 0, 2. Not every table has the value of Y-intercept, so we're definitely going to learn how to find the value if it's not obviously stated. But so your Y-intercept, one more time, is the value of X being 0, and then Y would be the actual numerical value. So from here, we're going to check out a different formula of finding the slope when we don't have a graph or when we don't have a table. So it says method number 2, come on, refocus, use slope formula. So that slope formula is an official formula that is listed on Star Chart. You will see and work with it a lot next year as well. And here it goes. And the value of slope is y2 minus y1, x2 minus x1. So one thing I wanted to, before we get really deep in this, when you are subtracting, you're finding the difference. You're finding the change. So what we did here and what we are doing here is very similar. Very similar. So our slope formula is using coordinates. Where do we get these coordinates? We're going to get these coordinates from the table. So we've done this for our proportional, non-proportional analysis. So if I wanted to take these values, and I'm going to just take a couple of them. My first coordinate point would be -1 and -3. My second coordinate point that I will be using 1 and 7, keeping them fairly simple. So they do not have to be following each other. They just two values from your table. So as you notice, your formula says x1, y1, x2, y2. What are they referring to? So in our list of values, these are coordinate points that happen in the order of appearing on your line. Okay. So in my list as well, when you see two coordinate points that are given to you, the first coordinate point would be x1, y1. Second coordinate point would be x2, y2. So what do we do with these values? We determine, well, how much did y value change? How much did x value change? So let's plug in. Again, super important. You are finding the difference. You were here, now you're here. So you were subtracting 7 minus -3. 1 minus -1. Now, I did want to give you right away example with negatives, so we see how these integers come to life again. One more time. 7 plus 3 and 1 plus 1 will give us 10/2 that reduces to 5. That's what we just saw earlier. So we have two of these methods that we can use to find slope, from the table or from coordinate point. Let's do this again. Example 2. So usually you are not given two options, but as we learn in this process, we are going to use both. So first one, identify the pattern. Again, pattern of change. Change in y, and we're going to divide by change in x. So, well, here we go. X changed by 2, positive 2. Your numbers are growing. Oh, well, the y values are decreasing. Hopefully you see, my friends, the numbers are getting lower and lower, so it's a -4. So our pattern is a -4, so we have decrease in values, so they're falling. And so then this is by 2 reduces to -2. So yes, our anticipation is that the slope formula will give us the same result. So let's check it out. So y2 minus y1, x2 minus x1. And what I'm going to do, again, just to prove your point, prove my point, is to pick numbers that are not next to each other. So I'm going to use the first point. So this is point number 1 because it showed up first. And point number 2 showed up second. So if you are seeing these questions in a worksheet or on the Quizlet or Quizzes, they actually will say, find the slope from these two coordinate points. They're simply going to list the points for you. So this is going to be x1, y1, x2, y2. So let me go ahead and zoom in Again, why is this first? Because it showed up first. It's literally first on the list. So that's why we don't guess. We're like, oh, this showed up first. Let's do this. All right. Negative 16 minus 0. Negative 16 minus 0. 4 minus negative 4. So a lot of times your values in your table are going to be really nice. We hardly see any fractions or decimals, a lot of integers. But please, please, please make sure you're not doing this in your head because of all of these negative numbers. Lay it out, label, put them in the formula. Negative 16 minus 0 will give you negative 16. 4 minus a negative 8 will give you a 4 plus 4. It's the double negative that turns to a plus. That gives us an 8. Negative 16 divided by 8 reduces to negative 2. Voila. Both methods gave us the same result. So you are definitely welcome to use either one. Table, it's very visual. You can see the change. If you don't have a table, you can still plug these in. You can make your own table. Just keep in mind, keep the order. Negative 4, 0. 4, negative 16. What is the change? Negative 16. What is the change? 8. Boom. Same relationship. All right. So if you flip on the other side, I have a few tables for you. Let's give them a try. So again, I wanted for you to see the process so you are trying yourself and trying to determine some of these values on your own and getting some confidence. So we're just going to, again, just work on finding the slope. So don't worry about this y-intercept for this point. All right, y. Y values are decreasing. 20, 23, 26, 29, they all are getting smaller and smaller. Negative 3 is the change. So they're falling by negative 3. My x values are negative 2, negative 1, 0, 1. Oh, they are increasing. Here's your slope. Again, you want to make sure that your pattern continues. So sometimes it might not be this obvious. So double check every set of numbers. So I didn't just skip or didn't just stop at the first one. I went through several examples. All right, number 2. 10, 15, 20, 25 plus 5. I am observing my pattern, increasing by 5. This is the change in y. Please make sure that you're also writing decreasing as a minus, increasing as a plus. So then in your ratio, it converts correctly. Our x values 1, 2, 3, 4, easy breezy, plus 1. 5 over 1, slope is 5. And of course here, slope would have been negative 3. Number 3, ooh, some negative numbers here again. Negative 8, negative 4, 0, 4. It is increasing by 4. Again, I'm not setting up the ratios. I'm not going to say negative 8 over 2, negative 4 over 4. No. I'm looking at the change in y and then change in x. Sometimes they're really straightforward. Look at this. A really nice set of numbers. And they're all very nice. Just pay attention. 4 over 2 reduces to, yep, am equals 2. All right, next 3 questions, 3 graphs, or I'm sorry, 3 tables. It's very late. I should not have been doing this so late. But please pause the video. I would like for you to find them on your own so you can quickly check and self-assess how do you feel about finding the slope from the table. So pause the video and then complete the tables and then see if you found correct slope. All right, hopefully you have the same answers. So yes, we're going to leave 5 over 3 is 5 over 3. And then you have a little bit larger numbers, negatives and positive, all reduced to 3/1 or